Okay.
Okay, just one thing. Here we go. So thanks for the invite. And we're going to talk a little bit about the approach that we have here at the University of Glasgow. I think Andy introduced some of the ideas that we're talking about here already, which has done my job. I'm going to talk about some introductory things. I call it the good stuff, why we do what we do. Just a little bit about our philosophy behind the way that we've approached teaching R, or actually data skills, as we like to call it, more than just R, because the R inside D-SHAR is for reproducibility. And then a little bit about our pedagogical approach and curriculum before handing over to James, who's going to talk about our staff and student support and how we all work together to do the stuff that we do. So starting with the really cool stuff. And the reason I'm starting here is just to show the kinds of stuff that our students does, a little bit like Andy was talking there. So I'm talking about 3 projects. These are 3 student projects that I've run over the last 3 years. So, you know, I just chose the 3 latest ones. And here is just the visualizations and the analysis that our students undertook for this. And I have to say, I've really enjoyed these projects. They are a real, they're really fun to do. They're really enjoyable. I learn a lot. The students learn a lot. We take new research questions that we're interested in, things like that. But it might surprise you to know that these are not dissertation projects. These are actually projects that I have, they're small scale group projects. So our students are randomly allocated 6 at a time to a supervisor in the school, and we work with them on their real first taste of research. And so I work with the students on, I give a few options, we choose one of the options, we work on a research question together, we work on methodology together. I just always make sure that it's a sensible method that we will be able to analyze at the end, but they do most of the work. And then when it came to the analysis, every single one of these years, I kind of like always approach it in the same way. It's like, okay, it's all going to be fine. It's all going to be fine. Everything's going to be good. And then the students pull out of the box this stuff. So 2019 students, they opted for a mixed linear mixed effects model with random slopes for participants and stimuli. Wow. Okay, wonderful. Regression and logistic regression the next year. This year, I suggested the analysis for students because the focus was much more on the methodology. We were using open-ended data and they were coding it. So which meant that they had to do a little bit of validity on the coder. So they figured out how to do interclass correlations, which is a concept, an idea, and thing that they had never met before. Okay, so all of these projects, they came with things that they hadn't really come across before they started the projects. But this is what they did. And this is their real first taste of a proper research project. Then they move on to dissertations and other wonderful things happen. But I can say hand on heart that our students come away with confidence and skills to take an unfamiliar data, and look at the research question and make and execute an analysis plan and communicate those results. They understand what's going on here. I understand what they wanted to do, and they choose the best analysis for the research question at that time from the skills that they have available. The other wonderful thing that we have is a lot of gifts for the community. We have been working on our materials for a while now, and we're in the process of making more and more and more of these materials. Our hex stickers are growing in number all the time. Maybe they're not going to fit on the website soon anymore, but these are all materials that other people can use. The one good thing about our things are that, and James is going to talk about this a little bit later, that when we have new staff members come in or new people coming in and they need to take on projects, or they need to take on teaching statistics or supporting labs and things like that, these materials are there all the time for them to either brush up on their own skills, or the other thing that they can do is sometimes staff have to take over classes, and they can do that because we have this base set of materials that we use, some consistency in the way that we teach. And we have been developing this for a number of years. We started about 6 years ago, as I recall, with the first staff training on this, and it's just been growing and growing and growing ever since. Okay, so just talking a little bit about the ideas behind how we do this, I'm going to be focusing on our undergraduate curriculum rather than our other curricula. So, but we have 4 years in which we teach students, but there's 2 years of very formal training and then 1 year when things change a little bit. So that's where they do a little bit more advanced stuff. They have one more year of formal, one more term of formal statistical training, but they move on to more option type courses and things like that. So most of what we do happens in year 1 and 2 in our undergraduate degree. As other people were talking about before, and as Andy was saying before, there's a real disconnect in some of the way the psychologists in the past have seen data skills or data analysis, or really looking at our analysis. And so a traditional focus has always been on only half of what we need to know in order to do our analysis. And this has been on kind of like visualizing, modeling the data. You might call it modeling, but we call it statistical analysis, and communicating that. And that has been the traditional focus, where in terms of formal teaching, whereas there's little formal teaching or little part in the curriculum very often for what makes up the bulk of what goes into an analysis plan. So what we do is we focus on the whole of the analysis plan, and we focus on all the different kind of analysis skills that you need in order to go all the way from where you have a spreadsheet of data or even a word, you know, maybe things on paper that you need to enter into a spreadsheet, all the way to transforming it, tidying it, processing it, reshaping it, to modeling and communicating. So I think that is a big thing that we changed. And so our curriculum now really emphasizes these essential data science, we would call them graduate skills, that have been overlooked by traditional approaches in teaching. And the method that we use, so, well, there's different interpretations about what we do, but the way I always think about it is that we're actually teaching students computational skills or computational thinking skills. This is really the skills for breaking bigger problems into smaller parts that you can solve each at a time. You need to be able to do this, to tell a computer what to do. And very often we don't have access to that information because as researchers we become very expert at it, and we were not always taught this formally. When we started this, there were 6 of us mostly involved in this, and 4 of us had programming experience. So some of us had been taught formally about, you know, in this way, thinking in computational skills, but all of our training was very old. And I think in modern times, there's a lot more emphasis on how computer programming or how coding is taught, and people really focus a lot more on these computational thinking skills. But at the time when we started, we didn't really know that, to think about it from that perspective. All we knew was that there was a big gap between how we were doing things and how students were doing things. But when you think about an analysis plan, do consider the fact that you actually do have that we actually do use these things. So this is my traditional analysis plans that I used to do. I would import data. I would get data from somewhere somehow, and I would import it. But then I would be doing data processing and reshaping, some of it in Excel, some of it in SPSS, maybe transformations in SPSS, some other things in Excel. I would do assumption checks, some in Excel, some in SPSS. I would do visualization and descriptives, again, some in Excel, some in SPSS. Statistical analysis would come towards at some point, and that was normally done in SPSS, although if I want to do a quick correlation, I might do that in Excel. So it's kind of like switching between different packages or different kinds of programming environments. And then I would be reporting that using a word processor. So the skills that our students then would need to do when they actually were doing their dissertations did rely on a lot of these kinds of things that were hidden behind, that they hadn't seen before. And this caused a real problem for them. They didn't understand very often what they were doing. So the way that we do it at the moment is, or the way that we've changed it, we've actually, as a formal part of what we do all of these different parts. So students learn about importing data, they learn about data processing, they learn about reshaping things. And so our formal curriculum really includes these things. And this just emphasizes this for you again, just that our traditional formal training did include assumption checks, they did include statistical analysis and reporting, which would include visualization and things like that. As an added bonus, we would add power analysis into it. But looking at our formal teaching now, and actually we give students so much more. As part of the formal teaching, they learn about data simulation, they learn about power analysis, data importing, data processing and reshaping, assumption checks, visualizations and descriptives, statistical modeling, reporting. All of these things are part of the formal thing. And all of them have an equal part. It's not always taught in that particular order. I think we can do more power analysis a little bit later on. We maybe do data importing a little bit earlier on and data reshaping and things. But really, when you come to doing a research project, all these things are important. Simulation is really important because it helps students to figure out how, or at least think about what their data is going to look like before they decide on their analysis plan. The other thing is just a little bit about student assumptions. So it used to be my discussions with students, and it's very much based on my mentoring discussions with students about what they thought analysis was and I would do these kinds of discussions before I would start the process of how are we going to actually do our analysis now, just to check where they were and where they needed support. For them, the focus was on assumption checks, analysis, visualization, reporting. Okay, sometimes they didn't do reporting. Often I had to tell them, and how are we going to report it? But now when I come to a dissertation project, for instance, and we get to the analysis stage, and I have these same conversations, it's very clear to me that students understand that there's so much more to data analysis. It's kind of like, what do I do with the data? How do I get it into the package that I'm going to use? What is important? How many participants do I need? How do I kind of figure this kind of stuff out? And so all of these things, when I talk about them, I don't actually have to really discuss in detail with them. It becomes part and parcel of the way that they approach any analysis. Now, it's not all roses and unicorns, because we still have students who really struggle and students who have real issues with data analysis and with coding and all these things, the same as everybody else has talked about here. But traditionally, what students would focus that imposter syndrome, that I can't do this, I don't know what my skills are, I can't point to what I'm supposed to be doing, I have issues here. They would focus that on statistical analysis. They would focus that on, I don't know how to do an ANOVA, I don't, what do I do there? And that would be the kind of like locus of their imposter syndrome. Whereas currently, for them, the locus, and this is the discussion, this is the pedagogical or the pastoral discussions I need to have with students, is that they do worry about the coding. Am I going to get it right? Am I going, is this going to be the right way to do it? But it's not on the statistical analysis. That is not where their issues lie at the moment. It is on the coding, and we're working on that all the time to try and get them confident. And then, of course, we have very confident people, as we always had in the past, who just take this stuff and just run with it miles ahead of anybody else. So very briefly, our pedagogical approach, because time is marching on and James needs something. So we build skills gradually, very much like Andy was talking about there, and we put a great emphasis on practice. So we build a foundation in processing and visualization of data, which is data wrangling, really, another way of putting that, before we actually move on to analysis. And we slow it right down. We try and teach a few things really, really well, really lay those foundations, build those foundations properly, and then we start building on top of that. And then the kinds of things that you can build on top of that is really, really strong. And here is just a very brief overview of our curriculum. This will be available afterwards, so you could have a look there. But we have a 4-year structure. However, we teach most of the substantive content in terms of getting students to the point where they can run almost any analysis that you would throw at them as an undergraduate student. They can do that after 2 years. And we do spend a lot of time working on how to use R and Rstudio. we introduce Markdown right at the beginning as a good way of them coding and keeping their scripts tidy and things like that. We teach them coding, the kinds of skills of solving problems, finding, how to debug, all these kinds of things. We move on to data processing, visualization, some things on probability and descriptive statistics. In year 2, we recap those level 1 skills. So that's kind of like the practice element, kind of like, we're not assuming that you know it all just after 1 year. So we go back and we practice these things again and again. They learn a little bit about simulating data, but not a lot. That comes more in their level 3 course. They learn about power descriptors, inferentials, which include correlations, regressions, t-tests, ANOVA, also chi-square. And we really focus on teaching the GL in the general linear model. So in those first couple of years, the other thing was that this was a substantial change in the way that we did things, a big structural change. And so we had the opportunity to review the whole of our curriculum and how we teach statistics and methods and the practical course and all of that together. And so all of that works together. We try and make it as a seamless whole. So they have lectures in qualitative and quantitative methods, for instance, and they have lectures in qualitative and quantitative analysis. And we focus a bit on hand calculation to build those computational skills that they need. Practical skills, courses and labs, which are part of this whole thing. And then we also look at the assessments, which are often exams, reports, and homework. Then in year 3, they move on to a much more, the main stats course there, which is on statistical modeling, uses a simulation-based approach. And they also have an option of doing a psychometric course. Some people choose that and some people don't. But there we also have these small scale quant and qual projects. So the quant project is the one that I was talking about earlier. Then they have lots of options courses, some of which are advanced statistics. They have their dissertation in year 4, and there's a variety of different assessments that we do on this. And finally, before handing over to James, I'll just point out that we have a smaller version of this available for our conversion cohort, which we have to get up to the skills for a dissertation with just 6 months, because we only have 2 semesters and then they work on their dissertations after that. So we've kind of like pared down to the bare essentials. So we don't have the fancy things like mixed linear models, but mixed effect linear models, but we do have other things there. Okay, I'll hand over to James now.
Thanks. Fortunately, mine's the smaller bit, and I've got to do my best public health presentation impression to get Helena to advance things. So my bit's focusing more on the experience of coming into an established department. So I've been working at Glasgow since September. So it's a little bit more of what I've noticed, having come from somewhere that didn't teach R to now being able to teach it and see how things work, and the sort of things I've noticed. So Helena, if you want to go to the next one. So what I'm going to do is break it down in terms of support for within courses, outside of courses, and then professional development. So when we talk about the undergraduate curriculum across 4 years, it might sound like we have much longer within the Scottish framework, but within those first 2 years, you have students from outside of psychology who can select psychology for a second course. So you could have people from archaeology, you could have people from theatre who would choose psychology. So they're much further outside those expectations. So when people are worrying about, oh my God, like, our psychology students going to embrace this stuff, how are they going to get used to R? We have people from even further outside the expectations of psychology. So the support we provide them is really important. So within specific courses, we base everything around teams, and having these avenues of support is really important, so they can reach out if you have questions, problems, different people can respond. So we have staff answering questions, students answering questions, really gives them the motivation to help out. So there are in-person labs, so similar to some of the other programs we've heard about, where it tends to have more of a co-teaching approach, where there's never one teacher at the front trying to do everything. It's normally with a graduate teaching assistant, could be 2 lecturers. Some of this involves live coding. across the last couple of years, been a little bit more difficult to have all this stuff live because of pandemic. So most of the labs have been online. That makes it a little bit more difficult to have that approach. We have group assessment. So this is really useful for students being able to learn from each other and like sort of build on their own strengths. So one of the assessments we have is they have to work on a pre-registration. So they have to be able to work in small groups, code things like a quick power analysis, analyze a sort of very short version of the data they'll have to demonstrate their analysis plan. And they will do this in groups where they can provide support to each other. And then the final assessment tends to be them working on their own. So they can both demonstrate those skills independently as well. And then the main thing I'm going to focus on is these course specific teams channels. So being able to highlight where these avenues of support are to be able to answer specific questions. So like you can see on the right, this is for one of our level 2 courses. And there are different channels that they can ask specific questions for. So the sort of lecturing team on that course will be able to answer questions. Students will be able to answer questions for the other students, relink to when they've been asked before, because of course people don't scroll up and see what's gone before. So you can sort of provide a link so you're not spending all your time answering questions. And then they can also have closer to one-on-one support where they can book support sessions with graduate teaching assistants. So that's also important for that community. It's typically our PhD students to provide them with some experience of teaching this stuff as well. So if you go ahead, Helena. And sort of in contrast to, it was interesting to hear about some of the other experiences where tends to be, as soon as they get to more independent projects, so these smaller projects, their dissertations, not wanting to step on toes in terms of their dissertation supervisor, where we have a slightly different approach because of this sort of teams-based support. We also have these sort of help and analysis channels that people can post their problems to, and there's a much wider range of support. So seeing some of the comments about how would this work when you have such a small teaching team and there's a few number of staff taking a massive load, where this is where people can jump in and answer questions from each other. And in our experience, there hasn't been too many issues with sort of stepping on supervisors' toes. People tend to really appreciate and appreciate that support from other people. So you have staff office hours, people can drop in once students quickly start to learn the sort of names of who they can go to for this kind of thing, but you can have dissertation students popping into your office hours and asking a question. It could be like some of the really minor things. And then we have these help pages, like an example below. This is a dissertation student, but just asking a general question, which anyone can pipe up for. If you want to go next. And final thing for this is some staff members are also hesitant about some of these things. So not everyone is confident, people are always learning. So we also have this sort of continuous professional development where we have a methods and meta science group where there are things like Coding Club, which Lisa's linked to in the chat, have these weekly seminars hearing about different things around methods and meta science, and also analysis support pages here. So even when you're a staff member, you're teaching this stuff, you don't always know the answers. So you can post questions here if it's something a little bit more advanced. Some people can pick it up. This example at the bottom was a staff member, and there's actually one of the students who provided a solution. So it is really good for providing and giving the students that opportunity to help once their skills develop as well. And tends to be really nice to see. And next. And the final thing we're going to talk about is really the sort of the things I've noticed as a new starter come into this department that has this already established. So the first is just attracting relevant expertise. So this was how it was worded in the job spec when I applied. So it does become the expectation that this is a skill someone would have, and being able to work and teach with R. So it's a little bit different than sort of having that change when you're already there. But Helena was there when they changed from teaching SPSS different things to R. So happy to take questions later on for that experience of what it's like to sort of transition. The thing I've really noticed, and Helena's talked about that data skills reproducibility approach, where R is almost secondary here, where what it really frees you to do, we think it's the best tool, but you really see the impact of this when it comes to dissertation students. So in my experience and how I'd seen it being taught in previous universities was, you get these nice, pretty data sets that are really easy to work with. But as soon as you get to your dissertation where you have to work with raw data, you have no idea what to do with it. So being able to see these students from their journey and hit their dissertation, having some of these data skills really shows where it comes into its own. The one thing that was sort of to be mindful of was familiar yourself with materials you're working from. So if the students are being told one way, like what do you expect students to know at that particular stage? And it's been really beneficial for me sort of being integrated into the department where, because we have these open educational materials, it makes it much easier to collaborate, advance the content. For example, before I joined, they wrote a tutorial paper on data visualization in R. Me and a colleague last week adapted the materials to teach a workshop. So being able to build on that content makes it really easy and helpful to sort of integrate into the department. And last slide for me, Helena. But then in terms of some of the challenges, talked about from Trent's experience of what do you use? Because in comparison to SPSS, if you want to do a t-test, you click the menu option that says a t-test. But when it comes to R, there's more than one way of performing a task. So there's this distinction between, do you use base R, do you use tidyverse? Personally, we just focus on tidyverse. But understanding what the students would recognize and what they're comfortable with. So I taught R myself, so it was like a weird hybrid of base R and tidyverse. So being able to understand how they would do things, but then following on to the second point, we had a chat with some of our other new members of staff about how they found it. And it can be sort of like a staff level of imposter syndrome where they worry about like teaching the right way. We're like, what have the students done? What are the expectations? Do you have to be perfect in every of this stuff? So the happier answer is they tend to get pretty confident in their abilities, embrace the flexibility that R offers them, sort of recognize there are multiple options. Saw some of the comments about, oh my God, is it okay to Google the answer? Where if anything, that is the workflow of a programmer. If you don't know the answer to something, it's almost training in those skills to learn how to do it. And it's that flexibility, that problem solving that really comes into its own. And to finish up, Helena, really our take home messages are, it has given us a lot of opportunities. So being able to teach this way, particularly culminating their dissertation, it's so valuable then being able to draw on those data skills rather than just, should we teach R, should we teach SPSS? That really is the key thing, being able to have those data skills that they can use in other jobs, not just, can you do psychology statistics? The different levels of support ensure both staff and students can advance with their skills in these areas. And embracing these open educational materials really helps to move beyond this very siloed approach where you have your level 1 and they teach their thing, level 2 teach their thing. It has this nice integrated approach across the years. So thanks everyone. And Helena didn't give me much time, so short time for questions.
Sorry about that.
No problem. So I hope you can hear me. If anybody has any questions, please feel free to raise them in the chat or raise your hand. But if not, that's fine. We're right at the kind of the end of this session anyway, and we can return to these questions, any questions that arose from this talk or any other talk in this session. We can raise them again in the general discussion later. So oh, here's a question. So can you see that in the
Yep.
Okay.
Kai, so we have multiple approaches to this. So firstly, we do have an Rstudio server set up, and that is kind of like a backup in case students can't do things, but we encourage students to use their own machines wherever possible. So we try and get them to download the materials and we make that available. Every year, at the beginning of the year, I pass around a very clear message to staff and students, update your R, and I make all those resources available. And that just happens on an annual basis. And then that is, so we update our server and the computing labs. We update all of that stuff at the same time. And so just kind of say to people, look, this is what we're working on at the moment. This is likely that your materials are going to work if you update now. But yeah, it's really variable. We have computing labs and students can book those. We have the Rstudio server and students can use that. And we really encourage them and support them. I often have a drop-in hour where it's just kind of like, come, I'll solve your issues with installing. That's my job. Oh, thank you for the compliment.
Yes, indeed.
I'm very happy to answer questions. This approach has been a wonderful opportunity for us, I have to say. As I say right at the beginning, a big structural change like this, and from that we were able to review our entire curriculum in teaching stats and methods, which, to be honest, is a great privilege. And that is the way that I would always look at it. We were privileged that we were able to do this.
Okay, well, I think we should call it a day. So actually, there's just one question that just popped up there when I was talking. Helena, do you want to address that?
I can get that.
Okay.
So in psychology, because of the general structure that the Scottish degrees have, where you do lots of things to start with, we've always had a little bit of shift and movement. Some students come into psychology. This was the case when we had SPSS, or even from the perspective of they come into psychology, they think they're going to be counseling psychologists, and they realize that there are experiments and they have to learn the scientific method. That was a stumbling block when I started learning psychology. Then the next stumbling block is, okay, you actually say that there's data and I have to analyze it, and this is an impossible task. That was the case with SPSS as well. But it also flips around, because a lot of our students actually then change, so students can change their degree, they can change their degree plan at our university and in the Scottish system. So they can actually opt to come into psychology. And I would say, as many students as we might lose from this perspective, we gain others who choose to come into our courses as well. But there's other benefits. Like, for instance, I was chatting to some students, we have joint honours programs as well. And I was chatting to some students who were doing a joint between neuroscience and psychology. And so they have to go away from us for a year. And they were saying that, okay, so they use all the stuff that they learned in level 2 and taught some of the other students in biology about how to do their analysis for their level 3 projects. And so our students go away with skills that they're teaching other people. We have students that have chosen to make Glasgow University our users group, so it's like students supporting each other and things like that. So our students actually take the opportunities to extend their skills. Again, some students do it and some students are not that motivated, but I don't think that was any different. My experience isn't that it was different from when we were teaching it before. Nobody ever made an SPSS users group.
Yeah, just to end, so last thing, and then so I'm not stealing everyone's lunch. That also is pretty similar to MSc conversion. So I convinced Helena to include the curriculum for that, because that's more my baby and what I focus more on. And that's kind of that to an extreme level, where we only have a year that they're here. Because it's a conversion course, they haven't done psychology before. And we actually have 2 pathways, where some are MSc students, some are MA students. So you can either come in from education or you can come from psychology. So one have a science background, the others have a non-science background, and they're all in the same class. They learn, it's obviously a stripped down version, but it's still starting with data wrangling, data visualization. We get them up to a point of they can do multiple regression. So that's all within, it's like a semester and a bit. So up to Christmas, and then they have about 3 or 4 lectures after Christmas, and then it switches to qualitative methods. So they're probably quite a representative sample of whether this would suit everyone. There's this spectrum of how much people enjoy it, how much people have embraced it. But if anyone's taught people how to use SPSS, don't matter what tool you use, they're still not going to like it. But this one at least gives them a few more of the transferable skills, providing the supports there. They all seem to get through it.
Okay, well, I think we should call it quits on this first session now. It's about 25 to 2 here in this time zone. And so we will resume at 2:30 UK local time, which is 55 minutes from now. And so it'll be the same Zoom link, and I'll open it up, say about 10 minutes before, so 20 past the hour, and people can stream in. Okay. Oh, sorry, I should stop the